Okay, so what I want to do in this session is talk about code quality. This is nothing really specific to .NET. It is specific to developing software. And we do that in different languages. .NET platform also is one of them in language like C# and so on. So the first question, of course, is why should we care about code quality? What do you think? Why? Maintenance. What else? Reusability, or that's what you said? Reuse, okay. What else? Reputation. Whose? The company's ours. Absolutely, right? You don't want to be behind a product that's, hard to. How many times have you been in companies and, people keep complaining about code, right? Okay, so those are good answers. I would give you mine. It's pretty simple. And that is, you cannot be agile if your code sucks. Simple that, right? So what's agile? In agile development, you say, we will take feedback from the customers and make changes to the product and go back and, release the changes based on their feedback. You say, okay, we can do that. And you're sitting in the meeting, and right in the middle of the meeting, as your customers are telling you what kind of change they want, you realize that would require changing that module of code that everyone in the company fears, right? And if you touch that module, you cannot go home for 2 days. Now you're going to convince your customer, that is really not a good thing to do, right? So forget agile development. If your code sucks, there's no way you can keep up with it. So that's one of the reasons why we want to make sure. If your code, it's kind of like having a car. If you want to drive from here to, let's say, Mumbai, you get in the car and start driving, and then you realize you have never taken the car to a mechanic. You've never changed the oil, and you have abused your car. Now you're nervous. How are you going to make it in the time you have on hand because you know that the car is not very reliable, right? It's exactly the same way. If your code quality is poor, you cannot possibly keep up with the change because it breaks and takes an enormous amount of time to keep up with it. So code quality is what? And here's a beautiful quote. Programs will be written for people to read and only incidentally for machines to execute. So one of the primary things about code is that we as human beings continuously read and understand code. And if we cannot understand the code, it becomes very difficult. So readability is important. How do you know your code is readable? Anybody? Say that again? Bingo. The only way you can make a code readable is to read it. I work with a lot of people. Experienced programmers will come to me and say, well, I write readable code. And I would ask them, has anybody read it? And they would say, well, my code is readable. I heard you, but has anybody read it? And they would say, no, nobody has read it, but my code is readable. Well, that's BS, right? Why? Because if nobody has read your code, that's hypothetical, oh, my code is readable. Well, if somebody reads your code, they're going to kick and scream and complain. And they're going to tell you how horrible your code is, because that's what everybody's code is. I'll tell you, I can never write good quality code. I'll tell you that very simple. If you tell me, Venkat, write code, I'm going to write it, and you're going to look at it and say, whoa, that looks horrible. I can never write good quality code. But I'm very good in finding fault with other people's code. So what I've learned over the time is, rather than me pretending that I can write good code, I will write shabby code and immediately give it to the next guy and say, you kick and scream about my code. In the meantime, I will review your code. And at the end of the day, we both have better code, right? So the whole point is, let's not pretend. Let's get it done the right way, which is to get some code working. And the reason is this. When we write code, everything is in our head. We understand it, right? You come to work, and people say, I don't understand this code. You say, what's your problem? It's clear to me, right? And every day you keep looking at it. The only thing you cannot do is take vacation. If you take a vacation, come back, you look at this code and say, my God, who wrote this? Well, that's easy to fix, right? Don't take vacations. You don't have a problem maintaining your code, right? But it becomes very difficult for other people to maintain the code. So that's why the best way to make a code readable is to read it. Well, the problem is that software changes. If somebody tells you, we designed an application and once we finished it, it never changed, what they're telling you is the project got canceled, right? If you build any software worth using, it has to change. And the bigger the problem is, the more the change is going to be. So what is important is that we have to make change affordable. And if we cannot afford to make the change, it is incredibly hard to maintain the software. And one of the problems with software is the cost of fixing increases as the time increases. Think about this for a minute. This is absolute common sense. You are working on a piece of code. 5 minutes after you wrote the code, you realize it's broken. You can fix it right away, correct? Because you're working on it right away. Let's say you come back the next morning and I say, hey, the code is not working, there's a problem in it, we got to fix it. Well, chances are you would be able to still look at it, understand, and fix it. Imagine I come to you about a code you wrote 2 weeks ago. What's going to happen? If that was me, I'm going to take time to remember, did I write that code? Right? 6 months from now, I have no recollection. I'm going to say I didn't even touch this. I was not even on the team at the time, right? And it becomes hard to remember this. So if you pull a piece of code written a year ago and you're going to fix something in it, it's enormously expensive because you got to reload all the context in your head. And how many times have you done this? Several hours later you say, oh yeah, I remember that project now. Well, that's good. We're somewhere in the territory now, right? And it's very expensive. So the more time goes from the time you write the code and you fix it, the bigger the cost of fixing. So one of the reasons for continuous feedback cycle is we can fix problems soon after they happen. That's very important. So how do you do this? There's an interesting list of 10 things to think about when it comes to defect. The first one is finding and fixing problems in production code is 100 times more expensive than during development time. And you mentioned code review a few minutes ago. Well, that's a great thing. Why? Because you're able to identify the problems while you're developing the code, not later on in production. 40 to 50% of effort on projects is avoidable rework. How many times you're repeating your effort in fixing things that could have been done correctly? And 80% of avoidable rework comes from 20% of defects. So that's the good news. We've got 20% defects, but that usually causes a lot of rework and effort. And 80% of defects come from 20% of modules. About half the modules are defect-free. And so there's a narrow area that you can focus on. 90% of downtime comes from about 10% of defects. In fact, if you really look at companies, they would have a list of bugs, huge number of bugs, and they would put cost towards it. And you would see that a small number of bugs are the most expensive to fix. And if we just pay attention to some of those, we could save a lot of time and money. Peer reviews catch about 60% of defects. And I don't want you to take this in the wrong way. Don't take this out of context. But given absolutely the choice between code review and unit testing, I have to tell you, I really like code review. And the reason is, code reviews give us such an incredible opportunity to make the code easier to understand, easier to work with, and also we can look for a lot of logical errors in the code. This is nothing new, but yet this is one of the things very often ignored. Very few companies, very few teams do code reviews. Now you say, well, why don't teams do code reviews? And there's a reason for it. In a lot of companies, the way they do code review is, there will be an email that says, we're going to have a code review on Thursday afternoon at 4 o'clock. Everybody come to room 507. And now everybody freaks out, right? The gal in the next cubicle says, you know what, I've got already behind schedule. I don't want to waste my time looking at the stinking code this guy wrote. I'm going to take off that day. And in the meantime, the guy who wrote the code, his code is going to be reviewed. He says, oh, that's a day I'm going to be beaten up at work. I'm going to call in sick. I don't want to come to work. In the meantime, the boss says, what's this code review thing you talk about? Oh, that's the day we invite everybody into the room, we project the code on the big screen, and then we critique it. And the boss says, oh, no. Last time we did this, there was a fight, we had to call the cops, and one guy quit. No code review for you, right? Code reviews are very politically motivated, and nobody likes doing it. Well, we don't do code reviews like that at all. The way we do code reviews is very tactical. So I write a piece of code, a module, maybe I'll spend half a day on it, maybe at most a day on it, and the minute I'm done with it, or I think I'm done with it, I'm going to take that one module of code, and I'm going to give it to him to review. And the next module of code I'm going to write, next task I work on, I'm going to have her review the code, and I will just switch between these people. One person reviews the code. And that's all we care about. And we don't bring a team of people to review the code. And in the similar way, the code he writes, I'm going to review it next week, and maybe the next piece of code he writes, somebody else in the team reviews it. So we tactically rotate this among people, so we don't really bring the entire team to do reviews. And the second thing we also do is we have enormous amount of respect for each other. We realize that the goal here is not to really, insult people. The goal is to get things better, right? There's no one person who knows everything. And the point here is, hey, I'm going to review your code, tell you what opinions are, but I'm not going to go over to the coffee machine and say, did you look at Siva's code? My God, who hired him, right? Well, this erodes trust in the team, right? And when you're listening to that, what are you going to listen? You're going to say, yeah, I don't know who hired him. And you're thinking, oh my goodness, I don't want to show me your code now. Because what are you going to say other people about my code, right? So that is one of the things we need to keep in mind is we build a trust in the team, then we begin to improve what we do. So there's a lot of these things we have to put in place for us to be effective in this process. Perspective-based review catches 35% more defects than non-directed review. What that really means is you want the code review from your peers. Some companies do this wrong. They invite architects and senior programmers to do code review. I call that the priesthood-based code review. These guys come with the big beard and say, you got the curly bracket in the wrong place. Who cares where the curly bracket is? We all know it's got to be the second line, right? So why do we care? The point is, we need to look for more things, logical. Hey, is the variable names descriptive? Is the function name descriptive? Is it easy to understand what the code is doing? Hey, did you have enough unit tests on this code? We not only review code, we also review unit tests as well. Those are important. But a better person to review this cannot be anybody outside of the team. So a peer-based review is very important. That gives us the benefit. One of the key things about improving quality of code is discipline. Disciplined personal practices can reduce defect introduction rate. It's not reducing defects itself, but reducing defects introduction rate by about 75%. So there are enormous amount of discipline that's needed when it comes to writing code. And discipline is a lot of times hard. It comes with a great amount of effort. It costs 50% more per source instruction to develop high dependable software product. The point here really is, if your company wants you to develop quality software, they must be willing to pay the price for it. You cannot say, I'm going to produce something of quality, but we will not give you time and resources to get this done. So it takes time and effort to create quality software. Sure, quality software can reduce the amount of time it takes to maintain the code eventually, but it doesn't come for free. It's something we need to be willing to spend on it. And so those are some of the things to think about. But still, what's really funny is this, that you see this quite often in companies, and what happens is, the evidence really is overwhelming. We know that poor quality software hurts everybody. It hurts programmers, it hurts testers, it hurts managers, it hurts companies' reputation, it hurts everybody. But still, what happens? We never seem to have a time to do it. But we always have time to redo it. You go to the boss and say, hey, I got to do this. No time, ship it. And then you create a mess. Now the boss says, fix it. It's okay, how much time it takes, we got to fix it now, right? And this is a very reactive approach we have in our profession. We don't put in time and effort, but we put in time and effort to fix the mess we create. So we got to break away from that. So this brings us to an interesting thing about technical debt. Anytime we touch code and we write software, we end up accruing a certain amount of technical debt. The first thing I would ask teams to do is, do you know what your technical debt is? And oftentimes we don't pay attention to it. We don't know what our technical debt is, or more so, we fear that we don't want to know. If we know it, we'll be in trouble, right? There's this ignorance is bliss. If you don't know it, that's better, right? So if you know what your technical debt is, in your iterative cycles, in your sprint, whatever you want to call it, you need to allocate a certain amount of time where you clean up your technical debt. Why? Because a technical debt is like financial debt. Let's say I go use my credit card, I go on my trips, I charge my credit card, and at the end of the month, I get a statement saying I owe a few $100s. And I tell myself, I don't want to pay that. I've got so many other things I want to go buy. It's so much fun to buy stuff, but nobody likes paying for those, right? So I convince myself, I'm going to send the minimum payment to the credit card company so I can take the money that I have and go spend more, and I'll charge more. Well, if I continue with this process, what happens? One day, I've charged so much that I've exceeded my credit limit. Now what happens? The credit card company sends me a letter saying that I've exceeded my credit limit, but you see I'm a very valued customer. So they increase my credit limit, right? Because the credit card company doesn't want you to get in trouble, they want you to get in real trouble. And if I continue with this for a while, all of a sudden one day, the amount I owe is more than a few years of my salary, and the only thing I can think of doing is to grow beard, change my name, and go to another place. Well, that's not the reason I moved, but you can get the point, right? It becomes very expensive, you cannot recover from it, and your solution at that point is to declare bankruptcy. Well, a lot of projects do it. They declare bankruptcy because you go to the teams and they say, well, this code is a ball of mud, nobody can maintain it. And nobody wants to work on this project because it's a mess, it's hard to deal with it, and it becomes very expensive to maintain the software. So at some point we have to continuously ask ourselves, what is the technical debt we have accrued and what are we going to do about it? So in each of the iterations, you need to have the discipline to allocate certain part of your schedule to pay off the technical debt. And the only way you can do it is you first of all know what your technical debt is and quit acquiring a lot more along your iterative cycles. So you have to take the time to continuously evaluate this and improve it. So, but how do you measure this? It's a very qualitative subject. It's hard to measure it. But measuring quality of code is something we got to be careful with. There are some metrics that are very poor, very bad metrics. One of them, for example, is line of code. Is it better to have more code or is it better to have less code? There is no real good answer to it. But the best answer there is don't use that metric, right? Because it makes very little sense to be looking at the line of code, and yet you hear people talk about this quite often. Hey, we want to know how many lines of code you have. That doesn't help really. So it's a very subjective thing. But quality is subjective, but there are certain ways you can make this. Is the code readable? Is the code understandable? Like I said, one of the best ways to know if it's readable or understandable is to go read it. Take this and give it to somebody else and say, read it and tell me what you think about it. Is the code very verbose? That's a sign of poor quality, when the code is very verbose. It's very complex. Are the variable names meaningful? If you don't have good variable names, it becomes very hard to maintain the code. But I'll tell you, coming up with a good variable name is incredibly difficult. Just because a variable name is large or big doesn't mean it's good. It can be as confusing as a short cryptic name. So a lot of times I would get the code out and somebody would say, yeah, that variable name is really not that helpful, why not this? And about the second or the third time, we may come up with a better name for a variable. And it kind of evolves. It's very difficult to do it right the first time. And one of the things is to come up with a simple code that works. Einstein said, any intelligent fool can make things violent and complex, but it takes a touch of genius to make things simple. It is very difficult to write simple code. It is extremely easy to write a very bad code. And there is one problem though. The problem is, and I'm sure you would realize this yourself, we fundamentally do not like to write simple code. We feel good when we write complex code, right? You go to somebody and say, hey, look at this code, look at this design, what do you think about it? And the guy looks at it and says, yeah, that's simple. and you feel let down. What do you mean it's simple? Give it to me, I'll be back tomorrow, right? Because nobody wants to say that's simple, right? And you go show this code and it's like, wow, I have the faintest idea what you're doing. And the guy goes to him and says, oh, Siva is really good because I don't understand half of what he does, right? Well, we like to develop complex things. And also it's job security. The boss says, whatever you do, don't fire him. Nobody knows what he's doing, right? So we feel good about creating complexity, right? It takes effort, enormous effort to make things simple. But that comes from a very extended effort and discipline. Hey, I'm going to make this really simple. And Ken Beck said this, one of the things about agility is to postpone the decisions of tomorrow to tomorrow. That is courage. It is to say, I don't have to do that today. One of the things you need to think about this, the code you did not write has the fewest bugs, hands down, right? The code you never wrote has the fewest bugs. The minute you write a line of code, there's a possibly a bug in it. So it's our courage to say, you know what, I don't understand this. I'm not going to write it today. I'll wait until I understand more. But a lot of times what we do, I don't understand it, but yet I'm going to write 3 classes for it, right? And we make things complex. So we have to really strive to make things simple. What kind of tests do we have? What kind of code coverage do we have? These are some of the things we could consider in terms of code quality. So how do you improve the quality of code? One of the very first things is to start early. You never come to a project and say, let's get this done, now we will focus on quality. That never happens. Quality is not something you can just add on later on. It is either built with quality or it doesn't have it. So if you're working on a project, the time to really invest in building quality is from the day 0. You put in quality and you continue to develop quality along the way. And you should not compromise. I know this is hard. We'll be tempted along the way. Oh, we have schedule pressure. Let's forget it. Forget the test. We don't have to do it today, right? Let's go get this done. But we have to know, hey, that's a compromise we're making, and that's going to come and bite us in the back later on. So we got to be careful about it. You have to schedule the time to lower your technical debt. Like I said, allocate certain times in your iteration. And this is something I really like a lot, is the make it work, make it right. A lot of times people get hung up on, hey, how do I design this correctly? What kind of patterns can I use here? I want to make this perfect. Well, there's no such thing as perfect software in that regard. So you want to make it work and make it better. But when I say make it work and make it better, you got to realize it's not make it work now and 7 months later make it better. No, time out. It's make it work now and 7 minutes later make it better. So that's where the repeated red-green refactor cycle we talk about in test-driven development is you get a piece of code working, and as soon as the piece of code works, you say, all right, that seems to be very close to what it should be doing. Now let's make it better. Now let's make sure this is of good quality. So don't try to make it perfect in the beginning, but don't leave it alone. You're not done until you've addressed the quality. But this requires continuous monitoring, and it also requires a change in behavior. Part of the problem here is attitude. We need to have the attitude to really improve the quality. And that means we need to have the attitude to listen, to be critiqued. Somebody's got to say, you know what, that code is really not good. And you need to say, well, okay, let me look at why it's not good, and maybe I can get better, right? We can't get insulted because the code is not good. It's not something we can do perfectly. We got to just get better. So we need to be willing to help, but we also need to be willing to be helped. But this really is a problem a lot of times. And one of the reasons why people don't want to have code review is they feel insulted. I don't want to show my code to you because then you would say how it sucks, and I don't want to know. I don't want to make it better. But the really people who are writing good quality code are the people who don't have that shame. They go show the code to other people and say, hey, tell me how I can improve. And this has nothing to do with experience. In fact, some of the most experienced people I know constantly ask for code review and improve it, and that's why they are better. And so devise a very lightweight, non-bureaucratic measure like I talked about earlier. So there are certain things you can do as an individual, and there are certain things you can do as a team. And this is important because a lot of times people will find a very easy excuse. You ask them why the quality is poor, they immediately will say, well, my team doesn't want to do it, or my boss doesn't want me to do it. And I think those are excuses. There are certain things you can do as an individual, and then you can expect a few things to be done as a team. The first thing you can do as an individual is you need to take pride, take the responsibility, like you said before, right? Hey, I want to make sure the code I am writing is going to be of good quality. I want to stand by this code. So you can come up with good variable names. You can come up with good method names. You can write, okay, so here's a question for you. How many of you here think, raise your hand if you think, long methods are good? One guy, long methods are good. You and I need to have a talk at 12:50. So one person thinks long methods are good. Why is a long method good? More descriptive. Who's that? Both of us have to meet at 12:50. Well, long methods are hard to understand, right? So how many of you have seen long methods at work? Look at that. Right? None of you wrote those long methods except those two guys. Right? You know long methods are bad. So here's an example. You go to your office on Monday, and your colleague comes to you, like these guys, right? And they say, how was your weekend? You could tell them, you know, the weekend was great. On Saturday, I went to the park with the kids. On Sunday, I went to the movies. But don't say it like that. You say, oh, the weekend. On Saturday, I got into the car, took a right turn, stopped at the light for 2 minutes, took a left turn, drove for a kilometer, turned right again, turned left again. Just keep going like this. About 5 minutes later, the guy is like petrified. He says, what, are you crazy? You say, no, I thought I'll tell you how my weekend was, like you write code. Right? Well, you don't communicate with people like that. You communicate in segments and say, yeah, I went to the park on Saturday, went to the movies on Sunday. Hey, what movie did you go to? Now we are focusing on the movie. Oh, was it really good? Was he a good actor? Oh, by the way, I really remember this other movie. Now you've gone into a different direction. That's exactly how you communicate. And guess what you do when you write code? You communicate. Well, there's a name for what I just said. If you're into patterns, what I just said is called a composed method pattern. A composed method pattern says that you don't go brrr on a method like there's no tomorrow, right? You say, I'm going to compose this method into smaller methods where each method gives me a chunk of information. It's not just about the size of the method, but a method needs to be at one level of abstraction. So when I look at a method name, that's what you do in that method. If I don't care to know the details of the implementation, I don't have to get into that level of details, that level of abstraction. So it becomes easier to understand. So occasionally you will hear a guy say, well, long methods are better because they give you better performance. Well, I have to say I accept. Long methods give you better performance. But that's when Nixon was the president. That was a long time ago. And we have a different architecture, different inlining capabilities, better compilers. So those things don't hold true anymore. So we got to be careful. So one of the things we should really do is not to write long methods. Because long methods are evil. If there is one thing we could do, we could create a law and punish these people for writing long methods, right? You still think long methods are... So, long methods are evil. Short methods doesn't mean that they're better, but long methods certainly are evil. Similarly, smaller classes rather than longer classes. How many of you have seen a class that runs 10,000 lines long? Yeah, scary, right? And you're like, wow, how do I understand this code? How do I comprehend this? So one of the ways to write better code is to read better code. That's one of the problems, I think. Most of us don't know how a beautiful code looks because we never have seen them. Because all that we see around is bad code, so we kind of think that's the way you write code. Right? But if you do take the time to look at beautiful code, I mean, there are times you have to look at a code and literally cry. It's like, wow, who wrote this? You want to go meet this person and say, tell me how you write this beautiful code. Right? You have to have that experience at least once in your life, maybe more, but at least once. But if all that you look is crappy code every time, then you say, well, that's our industry standard practice. Right? And then somebody says, what's your best practice? And you say, best practice is write long methods. Keep it simple. This is hard, like I talked about earlier. Write tests with high coverage. Run your tests before you check in code. These are individual responsibility, right? You don't need somebody to come sit with you and say, you will do this. You know what? That's my personal responsibility. That's my personal hygiene. Does somebody come to you every day and say, did you brush your teeth? I hope not, right? You do it because you know that's the right thing to do. Showering may be a little discreet, but still, right? But there are certain personal hygiene you maintain exactly like that in code. Hey, this is the way I'm going to write code because that's the right thing to do. And to check in code frequently. I can't tell you how many times I go into companies and they say, oh, we check in code every few weeks. What do you mean every few weeks? Well, think about this for a minute. If you don't check in code frequently, what are you doing? You are writing code and you have not checked in. You write more code, you haven't checked that in. And somebody next to you says, hey, maybe this design is overly complex. There's a simple solution. Immediately you say, don't touch my code. I haven't checked it in. I don't want to lose it. You protect it, right? Because you are scared you may lose the code. But imagine you checked in the code, and you just checked in the code, and somebody says, here's a better idea. Really? Let's try it. Yeah, this is much simpler. Thank you. You check in the code. Better. Or you try it and you say, you know what, this really is not working very well. Kick it out. I have the code in the source control system. I'm not going to lose anything. So checking in code frequently gives you the opportunity to code fearlessly. Imagine if you're going to be fearful to change your code. That's not software design. There's a different name for it, right? What is TDD? Test-driven development. No, that's not what we're talking about here. This is called threat-driven development. You're scared. Don't touch the code. That's code. It's software. No. Well, check in the code, then you have no fear. If you don't like the code, kick it out. Get it back from the source control. So checking in code frequently. And when I say frequently, how frequent is frequent? I check in code every few minutes. Literally. If you come and look at my log of check-in, you will see hundreds of check-in in an 8-hour day. Because I don't want to have fear modifying my code. If I want to go change a code, I want to go play with it. I want to try all crazy ideas because that's what is fun in developing software. Not to say, oh, be careful with my code, right? I don't want to be careful with my code. I want to be brutal about my code so I can try innovative things on it. So learn your language. There is no compromise for this. If you're programming in a language, you got to know it in and out. One of the things people say is, you got to know one level of abstraction below the level you're working in. That's when you know to get the command of the language, so you know exactly what you can do and try it. If you're switching between languages or using multiple languages, it's a little bit more challenge, but you got to know the differences. One of the things we need to do is to avoid the so-called cargo cult. Cargo cult is, you do things because it worked somewhere else on some other project. This is why one of the reasons I'm scared about patterns generally is because we say, oh, this worked on the other project, let's go use it. We got to evaluate every time, does it make sense to do that here? Is this the right thing to do? And like I said, core feedback and criticism. The more feedback and criticism you get on your code, the better it is. It's important to avoid the so-called Rube Goldberg machines. Rube Goldberg, I'm sure everyone in this room has built it, right? Somebody looks at your code and say, oh my goodness, why are you doing this? And you say, because it's extensible, right? That's the excuse we use, or this is more reusable. But we build code that's very complex, and I'm sure we can remove 50% of the code, and the code will still solve our problems. So it's important to really build code that's simple. Here's a wonderful quote. There are two ways of constructing a software design. One way is to make it so simple that there are no obvious deficiencies. There are obviously no deficiencies. The other way is to make it so complicated that there are no obvious deficiencies in them. How many times do you look at your code and say, I don't know what's wrong with this code, right? You don't know. It's so convoluted, so complex, you have no clue what's wrong with it. So what can you do as a team? You can avoid shortcuts. Shortcuts often give us trouble. Take collective ownership of the code. This is one thing we follow. We don't have territorial boundaries. I'm sure you've been on projects where they say, oh, that is Joseph's code. Well, you don't want to take ownership of code like that, right? That's like, you go to the streets and the dogs define territories, right? Oh, that street dog cannot come into this street dog. We're writing code, for heaven's sake, we're better than the dogs, right? So the rule we follow is you can touch the code, but the minute you touch the code, you're responsible for it. So don't mess with the code if you're not responsible. But if you think you can change the code and you can stand by it, go change it, make it better. So we have collective ownership of code. Promote positive interaction. Don't go to somebody and say, I'll tell you how your code sucks. You're not going to invite friends doing it. So it's a better way to communicate, hey, looked at the code, I'm wondering if we could write it differently, right? And the word we is such a beautiful word. Then we're not saying you versus me, hey, it's we, us, our work, can we do this? Then we are participating, collaborating with each other, and that's a better way to communicate. And constantly perform this tactical code review I talked about. So I already talked about the code review, so I'll move on. So we do a very tactical code review along the way. And one of the beauties of doing this is we can improve the code continuously. I heard this quote, really brilliant quote, from a guy, Brian. He said, code reviews make me a hero or make me smarter. I said, wow, that's pretty interesting. What does that mean? He said, most of the time, somebody reviews my code, and they come to me and say, here are ways you can improve it. And every one of those times, I'm becoming smarter because I'm learning from it. Once in a while, somebody would come to me and say, oh, I was reviewing your code. Oh, by the way, that's brilliant. I've never seen the design being done that way. And right for that moment, you're a hero because the person reviewing your code is learning something from you. And that's a really good thing. So code reviews can only make you a hero or make you smarter, so why would you not want to do it? So I can't really overemphasize the purpose and the need and the benefit of code review, but code reviews are a sociological as much as technical. So we need to really, think about this human interaction part of it. That's very important. Another way to improve the quality of code is to treat warnings as errors. I cannot tolerate warnings in code. I remember being on a project. They invited me. I'm a consultant. I said, okay, fine. What do you want me to do? We want you to add this feature. No problem. I checked out the code, and I hit the compile button. I'm ready to add the code. And it said there are 350 warnings. I said, okay, well, they didn't hire me to fix the warnings. They didn't hire me to preach. I'm going to ignore it. I'm not going to see it, as if nothing happened. I'm going to write the code. So I touch the code, and my other part of my mind says, but I'm curious what these 350 warnings are. I really have to see it. So I opened up the first warning, and the first warning was about this code. And the code said something like this. It was pretty interesting to see this. It said something like, if flag equals true, and the warning said, did you really mean double equals and not equals? And I looked at this like, wow, this is in production code. And these guys have set the flag instead of checking for it. And I should have left it at that point. Now I'm curious about the second warning. And it was even worse than this. And within about 10 minutes, I wondered how this product even worked. And now I wonder, why should I write more code on this piece of what, right? So it's important to clean out warnings. You cannot have warnings in code and keep building on it. How many of you have warnings in code? Okay, they're kind of racing like this. Yeah, we all do. I was telling this in a company, and I said, you got to treat warnings as errors. And they all laughed at me. They said, you're crazy. We can't do that. I said, why? They said, because we have a lot of warnings. I said, lot. Like 100 warnings? And they said, no, a lot. Like 1,000 warnings? And they said, you don't know what a lot means. I said, okay, what is lot? And they said, we can't tell you. Okay, it was a very large number that we won't talk about. I said, okay, if you had warnings, do you have more warnings today than you did 6 months ago? And everybody's like, yeah, of course we have more warnings today. Well, what do you do about it? You could say, well, I didn't really start this project. I just joined this project. There's a name for it, right? It's called karma. You cannot fix the past, right? But you don't say, your company, you know what, when I came, this code was bad, so I'm going to make it worse. Turn on. So how do you solve the problem? Well, here's an idea. You cannot fix thousands of warnings overnight. But the simplest thing you can do is write a stupid script that finds the number of warnings that is n, the number we won't talk about. And all that the script does from today is, if the number of warnings is n or less, it'll keep quiet. The minute you put one more warning in code, it will fail your build and complain to you, because you cannot. So you're putting an upper bound on the warnings that you have. Now if you do this, one programmer takes kindness and fixes one warning. And the script says, oh look, for the first one the warning is n minus 1. And that becomes your threshold, and you can over time reduce it. I mentioned this to a company. I went there 3 years later, and they said they still have warnings in the code, but there are several modules where they have 0 warnings. And in 20 years, they are getting to the point where there are no warnings in code. So put an upper limit on the warnings if you have them. And then that is one way to fix it. Okay, so that is something you could do, is to remove these warnings in an incremental fashion. The second thing you could do is to reduce complexity in code. There are ways to look at it. You could look at coverage. You could look at complexity. You can look at code size. One of the problems is duplication of code. The more duplication you have in code, that's hard to fix the bug, right? I was talking to a company and they said, oh, every 2 months we fix the same bugs. I was like, wow, does somebody actually actively put the bugs back in? He said, no, this code is duplicated in so many places, we don't have a clue where all it's duplicated. I said, how does it feel? He said, oh, that sucks. And then I said, well, every time you discover this, you remove the duplication, right? And the guy said, that's a great idea. Well, where do you go with it, right? So you have to remove the duplication, otherwise you will never be able to catch up with it. So code coverage is very important. Well, okay, you want to find the code coverage, but I want to emphasize one thing. Code coverage is like cholesterol number. If your number is bad, you're in poor health. If the number is good, doesn't mean you are in good health. I know this is not very encouraging. But the point is, don't celebrate good coverage number. But if the number is poor, you got to fix it. So it's just one thing that you have to be careful about. So improve your coverage numbers along the way. You want to reduce the complexity of your code. Long methods cause pain, or we have too many paths in the code. You cannot possibly write unit test on a piece of code that is long, because it goes to exponential proportion if you're going to start writing unit test on it. So you got to maintain the code properly. So one of the things you can look at is cyclomatic complexity, the number of decision points you take in the code, and that is something you can use to know how complex the code is. Well, in general, when you look at these things, you could put these together and say, well, okay, we want to write small code. We want to make sure it's less complex. So how small is small? There's no real number to it. I would say the least is you should be able to see the entire function in a window, and don't try to lower the font size. So with a reasonable font size, you should be able to see the entire function in a window. But more than the size itself, it's the level of abstraction. You want to make sure the code is in one level of abstraction. And again, remove the duplication in code, keep the code dry. Okay, so here's the way to think about it. If your code is not as complex, but if your code has a very high test coverage, then that is exactly where you want to be. The second row here is the beautiful place to be, right? That's where you want to be. If your complexity is low and test coverage is low, that's a risk. But if your complexity is high and your coverage or test is low, this is really a disastrous situation to be in. Well, you could talk about this in these terms, or you could use a different metric called change risk analysis prediction, also known as the CRAP metric. So you could actually prove that code is crappy now. You don't have to tell people that it's crappy. So run some of these tools and find out how crappy the code is, and now you can say, well, let's go fix these and refactor these pieces of code and make it a better quality by at least start with extracting the methods, if nothing else. So there are tools that you can use to find how crappy the code is, and you can make it better. In terms of code smell itself, there are quite a few things we need to think about. For example, some of the smells I can think of is duplication in code, unnecessary complexity, comments. How many times you look at comments and the comment says one thing and the code does something else, right? And comments are a smell in the code. Long classes, long methods, poor names. Code that is not being used. How many times do you deal with code? You keep looking at the code, but nobody's using it, and it's not being used anywhere. Inheritance is one of the abuse concepts. Convoluted code, very tightly coupled code. too much abstraction, overuse of design patterns, or where you're trying to be very clever in the code. I'm sure everyone has the tendency, right? You don't want to write simple code, you want to write clever code, but usually that causes more pain than it's worth. So one of the things we can do is continuously keep an eye on it, refactor the code continuously, reduce the complexity in the code, eliminate the technical debt as much as you can, and again, continuously make the improvement along the way. Well, how do we really make this better? I got some idea, not from a technical book, but from a non-technical book. Amazingly good book, written about 30 years ago now. And this book is called On Writing Well by William Zinsser. He talks about writing English. And the 4 things he outlines are keeping things simple, keeping things clear, brevity, and humanity. And it turns out, I was thinking about this, and I realized this is not about writing good English or nonfiction, it's about writing code as well. Because one of the things you want to do when you write code is to keep things simple and clear, and brevity, meaning small methods and small classes, and then humanity is very important for us to keep. So these turn out to be really good principles, not just to write English, but to really write better quality code. Also, exception handling. How many times do you see people throwing exceptions? Exceptions should be used in exceptional situation. A great example of this is the parse int method in C#. When you parsed integers, it used to throw exception. Then they gave you an alternate method that returned a Boolean condition rather than throwing exceptions. A lot of times we get into the habit of throwing way too many exceptions than we should really be throwing exceptions. So ask about how you can eliminate some of those. And like I said, don't write clever code, write clear code, a code that is easier to understand. And a lot of times we rush through writing code. It's important to kind of slow down a little bit sometimes so that we can write a better quality code and make sure that we have not compromised on it and have to spend the time making this better along the way. In terms of writing code itself, I prefer self-documenting code. I really hate comments, I'll tell you that. Because a lot of times comments tell you what the code is doing and it doesn't help you. A real comment should tell you why the code even exists. That's the kind of comments you really want. So try to think about writing self-documenting code as much as you can. I was at a client site and I actually came across this code. This guy had variables, and under that a programmer has written, God help me, I have no idea what this means. And imagine maintaining products like this. This particular product, I can't tell you whose product it is, but they sell a license for millions of dollars. And you can imagine the engineers maintaining this code, it's extremely hard for them because they don't have a clue what this very sophisticated application is doing. So it's important to have the discipline to write code that's easier to understand. So I think I said enough about commenting. One of the other things is I want to see errors on my face. A lot of times people use logging. Logging is a great idea, no doubt. But if you're going to spend time searching for these errors, then that's a sign that your support is going to be expensive as we go through. So you want to make sure you're able to fix these errors, and the errors should pop up. I understand in some applications security is a concern, but you can always provide a very nice way. You press the secret combination of buttons, it can give you enough details with the compromising security. So in other words, I want to be able to find the error details very quickly because that's time, that's money. We want to be able to quickly get the errors and fix it. So I'm running out of time here, so let me summarize. The first thing I would say is practice technical or tactical peer code review. Like I said, I can't overemphasize the benefit of code review. In projects I've done code reviews, our error rate has been so low compared to products where we did not do that. Consider untested code as unfinished code. I would not claim that I'm done with a piece of code unless I have written enough test cases for it. Make your code coverage and metric visible. I can't overemphasize this. If you make your results visible, that gives a fear factor. It's a pride thing. And a peer pressure comes in, and what's visible, we tend to make this a lot better. So make these things available to other teams in your company, and then people are under pressure to get things done properly. Don't tolerate anyone trashing your code. If somebody messes your code, take that very serious because that's yours, your products. You're going to be left with the mess to maintain, so don't tolerate somebody coming in and writing poor quality code on your product. Write self-documenting code and comment wise. I talked about this. Use tools to check quality as much as you can along the way, but do it incrementally along the way, and you want to use it continuously. Never throw in a tool later on at the end of this. And again, I talked about treat warnings as errors, and keep it small. Don't write long methods and large classes. And finally, keep it simple. Again, that's hard, but we have to learn and get better at it. A few references, you can take a look at it at the slides. That is all I have. Thank you.